Hello, welcome to Curated. Today we will be solving a problem called nested list weight sum, which is frequently asked in LinkedIn interviews as per online discussions. The problem statement goes like this. You are given a nested list that can contain integer or more lists. Each integer has a depth based on how deeply it is nested. Your task is to return the total weighted sum where the weight of each integer is equal to its value multiplied by its depth. The depth starts from 1 for the elements in the outermost list. Let's go through the input example to make it clear. In the input list, the first element is integer 1 and the initial depth is 1. So the weight of 1 is its value into the depth 1. The second element is actually a list. So every time we go one level deeper into a nested list, the depth increases by 1. The depth inside this list is 2. The first element inside this list is integer 4. So its weight will be its value into the depth 2. The next element is actually a list. So the depth again increases by 1 and the depth inside this list is 3. Hence the weight of 6 will be its value into the depth 3. Now add all of them and it will be 1 plus 8 plus 18. So it will be 27. This is the output we need to return. A naive idea would be for every integer, find its depth by calling a method say find depth, which will use depth first search, and then multiply the value with the depth found, which gives you the weight, and add the weight to the answer. With this approach, we would end up traversing the nested lists repeatedly for every element just to calculate the depths, which would lead to a time complexity of big O of n square, which is bad. So instead of finding depth separately for each integer, we can carry the current depth while traversing the list using DFS. Because whenever we enter another list, the depth increases by 1. So let us go through the dry run using the DFS approach to make it clear. We will be using this input as an example for the dry run. At depth 1, we have 1, the next element is 2, 3, the next element is the list 4, inner list 5, 6, and the next element is 7. The element 1 is an integer at depth 1, so its weight will be 1 into 1. 2, 3 is a list, so it will make another DFS call with depth equal to current depth plus 1, which is 2. The first element is 2 multiplied by its depth, and the next element is 3 multiplied by its depth 2. The list is completed and it returns the value 4 plus 6, 10. The next element at depth 1 is a list, so it will make a DFS call with depth 2. The first element is an integer 4, so its weight will be 4 into depth 2 plus the next element is the list 5, 6. As 5, 6 is a list at depth 2, it will make another DFS call with depth equal to current depth plus 1, that is depth 3. The first element is 5 multiplied by its depth 3 and the next element is 6 multiplied by its depth 3. So when you add them you get 15 plus 18. So it returns 33. 33 plus 8 is 41. So this returns 41. And the next element at depth 1 is 7. Multiplied by its depth 1. So this will just be 7. We have iterated over all the elements at depth 1. Now add all the weights, that is 1 plus 10 plus 41 plus 7, which is nothing but 59, which is the output to return. What is the time complexity? We go through every element only once, whether it's a number or a list. So the time complexity is big O of n, where n is the total number of elements in the nested list. And the extra space comes from the recursion stack, which can go as deep as the maximum nesting level. So the space complexity is big O of d, where d is the maximum depth of nesting. For example, in this case, d is 3. I hope the dry run was clear. Let's start coding the solution. You have been given an input of list of nested integer objects. Nested integer is an object with predefined class provided in the problem. It can either store a single number or a nested list of similar objects. It also has predefined methods to check if an element is integer or to get the integer or to get the list. And you are supposed to get the total weighted sum. As we will be going with DFS approach, let us first create a method called DFS, which will take the list of nested integer objects and the depth as input. Let us call this method from the depth sum method, and for the first time the initial depth would be 1. Now inside the DFS method, let us declare a variable sum and initialize it to 0 for calculating the weighted sum, and let us loop over the list of nested integer objects. So let's call each element as ni. For each element, check if it is an integer. We have a predefined method declared for that. If it is an integer, then get its value, multiply by the depth, which gives the weight of the integer, and now update the sum. Else, the element is not an integer and it's a list. So make another DFS call with depth increased by 1 and update the sum. After the for loop, return the variable sum at the end. So this will recursively cover all the nested lists and give us the total weighted sum at the end. Return it from the depth sum method. Let's try to run this solution on a couple of examples. Example 1 and example 2. Okay, we got an error at line number 92. Okay, this is actually supposed to be ni.getList. We need to get the list and then pass to the DFS method. Let's try to rerun the solution. And yes, we got the expected output. I hope it was clear, and if it was, do like and subscribe for more such videos. Thanks for watching.